Hello, Laura and Olga. I'm gonna wait a little bit until some other people join, but can you guys hear me okay? And you can unmute
Yes.
yourself. I
Yes.
just do that so that we don't get anything weird. Okay.
Hello.
good.
Nice to meet
Hello.
you.
And I'll say this again once it gets on, but um I'm recording. When I record, it does do the video or the like the recording has like your picture, but it doesn't have a name on it. So anyway, if that bothers you, doesn't bother you, just let you know. Because I'll post it up. So I'm gonna pull up some stuff while we're waiting for everybody. It's just now too. Geez, well, I hope you guys aren't the only two here, not because I'm not happy to see you, but just because I hope some more people join us.
I honestly thought that I was gonna be like the only one in this meeting because I still haven't taken any tests.
I had let's see. I have a math 0242 class and I did one of these and I think I had 3 people. And my face-to-face sessions that I did, out of 4 sessions, I had 1 person come. Total, not at each, like 1. The first time I came, there was supposed to be somebody there and they didn't come. The second one, there was only 1 person signed up and I asked them if they were going to come and they said, no, my plans changed, I'm not going to come, so I didn't go in. The third one, nobody was signed up for, and then finally the last one I had, somebody came, and that was a 1342 one. So that was somebody from you guys' group.
Okay, I have a question, another question.
Go ahead.
For both of the finals, because I'm in your other math class as well. Does it have to go through the respondents? Because I'm not able to do it.
Send me an email. I had to alter it for you in 1342, right? I had to give you the alternate.
I'm sorry?
For
Yes.
1342, I had to give you the alternate, right? Shoot me a quick email, either now or when this is over, because I'll have to do the same thing in the other class.
Okay.
So
Yeah, before you
so.
getting on, I had sent an email.
Yeah, if I because it's the same thing. So if you can't get on it in 1342, you won't be able to get on it in 0242 either. So
One more question. I'm sorry.
No, go ahead. That's what we're here
Both
for.
of Both of them are due today?
Both of the tests? 1342 isn't due till next week.
Oh, okay.
Yeah, no.
So which one's due today?
Yeah, the prereq one is due today, but the regular statistics one isn't due for a week.
Got it. Okay.
Yeah, that's got to be a little relief.
Yeah. Well, okay. So last week, Thanksgiving, I don't know, hope you had a good time for your Thanksgiving break, but I cooked for the first time and I think there was some tweaks there that my middle child and myself, we were just sick to our stomachs. We had a stomach ache and nausea and vomiting. So because I'm a medical assistant, I used to I went ahead and decided to text the provider that I was working with, and I'm like, what do you recommend? And she's like, just get a COVID test. I'm like, okay, sounds good. I felt miserable for about 4 days, so I couldn't do anything. Like I was thrown in bed.
Well, if
yeah,
you do
so
the
COVID results were negative, so we're good.
Hallelujah. So yeah, so the 0242, if you've been keeping up with all the stuff, and this is, if you're not in the co-rec class, don't worry about what I'm saying right now, the ladies that just joined. But if you're in the co-rec class, the 0242, that is due tonight. And there's a review in there you can do. and all. But the one for this class, for 1342, for the statistics class, it's not due till next Friday. So, and if I sound weird, I apologize. I just got an appliance put in this morning. It doesn't hurt or anything. It's just my tongue doesn't know where it belongs right now. It's like, where's everything at? It feels really weird. So I'm kind of lisping. Okay, so what we're gonna do, I mean, what I plan to do is go through the review that's on in D2L, but we can also answer other questions. So if you guys have any other questions that you want to do, and also there is a review already posted in D2L. So if you want to go watch that one, you know, we can't get through all the problems. And so if you want to go look at the other one and see if maybe there's, you know, some problems we didn't cover that you want to look at. And I told everybody, but I'm going to say it again, I am recording this. And so your video will show up on the recording. It doesn't give your name though. So like while we're live here, it says, you know, Patricia, Shelby, Laura, whatever. But when I record it, it only has the video. It doesn't have the names. So, and not only that, but really the only way you could get the link is like through the class. I don't make it public. It's like, I can't remember what it's called. It's like a level between like completely private and public. Like you could find it if somebody like went to my page, but it wouldn't come up if somebody just searched. So it's not really private, but it's not like completely public. Can you guys see this okay? Okay. So let me show you where some things are at that would be helpful. So if you are looking for things outside of this session, I am going to post this link right here where it's under recorded lecture videos and review videos. And then at the bottom, there's a live Zoom reviews. So that I will post it in here. And then there's already a 2-part Zoom review that was posted before from another class. So there's a live Zoom review for the final chapter 1 through 4 and another live Zoom review for final 5 through 8. So if there's something we don't get to today or that you realize later that you wish you would have asked about, you can go watch those and see. I try to go in order so that if you're trying to find something, you can find it. So I usually will say, okay, let's look at this page. Does anybody have questions on this page? And stick with that page and then go to the next page. So it shouldn't jump all over the place. You should be able to find it pretty quick if you're actually looking for something. So there's that. And then what that's based off of is if you go under the exam reviews, it's based off of this final exam review. So here's the actual exam review and a key. And I show the work and stuff on the key. So if you guys haven't done that yet, that's where that is the absolute best use of your time. So everybody good with that? And can you guys hear me okay? You can? Okay. Because I could put my headphones on, but I'm trying to cheat and use my headphones on my desk as a microphone so I don't have to wear them. But yeah, this is what we're going to kind of focus on today. There's also a right here, there's an example of hypothesis testing. This is a good place too, because it'll just give you some extra. Plus on the final review, I don't think there's an example from chapter 9. So this one has, if you see that little note there, A and D are like what you saw in chapter 7 and 8. And then, actually it should just say chapter 8. And then C is an example from chapter 9. So if you want to look at that one, I think that's the only one in the reviews that's an example from chapter 9. So is everybody good with where to find things to study and such? Guys all good with that? Okay. So, that said, I think what I'll do is I'll just open up that review and then just ask you, I'll do a few problems and ask you guys if you have any questions. So feel free to unmute yourself and jump in anytime. The only reason I have you muted when you join is just so we don't get anything crazy. And if anything crazy happens on my end while we're reviewing, I'm going to apologize ahead of time because I've got 2 cats and a dog and a teenage son, and Lord knows what might happen while we're on. I told him I had a Zoom review, but that, you know, he's a teenage boy, so. Okay, I'm going to download this. Open. I didn't download this because I thought, well, I want to open it up and show where everybody is. I should have downloaded it just to save the time of the download. So on the final, there is, I think there's 32 questions. And it's going to look basically like I took little snippets out of each test. So it's still going to be multiple choice. It's still going to have the same types of questions. The only thing different is, of course, I can't do, you know, 7 or 8 questions out of each chapter. It's only got 32 questions out of, what is it? We've got 10 chapters. So it's got like 3 or 4 questions a chapter. One of the biggest things I see people miss on the final is stuff from chapter 1. Because remember, chapter 1 was all those like definitions. That's all chapter 1 was. And people will forget to go back and look at them. They'll be like, oh, chapter 1 was easy. And I'll see people that do like good on the whole rest of the test and miss like 3 or 4 out of chapter 1. So don't do that. So make sure you go back and review like the different types of samples, the difference between like inferential and descriptive statistics, just all those things. And there's some examples in here, but you can go back and look at the other review, or go back and look at your notes. Holy cow, you think my computer was doing a corporate takeover here trying to open up a Word document. Good Lord. But yeah, so don't forget to go back and review the definitions from chapter 1, because that's one of the things that surprisingly a lot of people miss. They worry because everybody worries about, you know, you worry about chapter 8 with the big long hypothesis test, and you worry about, you know, going back and reminding yourself how to do the probability and all of that kind of thing. And then people, like I said, I think what happens is they think to themselves, oh, chapter 1 was easy. And they just don't go back and look at it. Okay, finally got this. No, don't do an update now. Yes, let me edit. So these are the kind of things you're going to see in chapter 1. And this review has, the final has 32 questions and the review has 29 questions. So it's pretty similar to the same length. So you'll see here, there's 3 questions from chapter 1. So on this first one, it says variables with values that are determined by chance. And the idea here is by chance. What do we call it when something's just by chance?
Random.
Random, exactly. I like to ask a question about randomness because one of the biggest things that I want you to get out of the class is understanding that the absolute best way to assign or choose things is randomly. The more that the researcher tries to manipulate or make it the way they want it to be, it actually makes it worse because you have bias. You have personal bias and you cannot avoid it. You just have it. So them trying to guess what the best thing is worse than if they would just be able to just randomly draw from the whole population. The problem is sometimes you can't do that, but it's still the best. Like if you can do that, that's the best thing. Okay, and then these are all the different types of sampling. So even though this question only asks about one, make sure you know what random, systematic, stratified, and cluster. Make sure you know what all of them are. So this one says questioning every 14th customer leaving a theater about the movie they'd seen would be an example of what type. So what do we call it when you ask every 10th or every 20th, or in this case, every 14th? You guys remember what that one's called? Well, is it random? So this is actually another kind of question about random. So would it be random if you asked every 14th person?
Systematic.
No, random is random. So when you start doing something that's, manipulating things, it's not random anymore. So stratified is where you do like levels. Like you say, I'm going to pick a group that's freshmen and sophomores. And then from each freshman and sophomore group, I'm going to pick males and females. And then from each male and female group, I'm going to pick, STEM and not STEM. When you layer it like that, that's stratified. So is that what we're doing here? That's not stratified, isn't it? We didn't do like layers upon layers, so that's not stratified. And a cluster is an intact group. So is it cluster? No. This is called systematic, because you have this system of doing every 14th customer. So that's called systematic. But again, go back and review what stratified, cluster, systematic, what all those are, because there'll probably be a question about that. And then the last thing, as far as chapter 1, it just asks, a television station reports 89% of Houstonians think the Astros are the best team. After surveying local people with the question, being Houstonian, would you agree that the Astros are the best baseball team? So what's that an example of? When you lead somebody, they're leading them into a specific answer by saying being Houstonian.
A faulty survey.
Perfect. Yep, you are right. Faulty survey question. A survey question shouldn't lead into a specific answer. So by saying being a Houstonian, you're kind of playing on that idea of, well, if you're a true Houstonian, you should like the Astros. So you're leading them into saying, yes, that's your favorite baseball team. So that's not good. You don't want to do that. You just want to say to people, what's your favorite baseball team? You could even ask people, do you like baseball? Okay, well, given you like baseball, what's your favorite baseball team? That would be okay, but you can't say, being a true American, do you like baseball? Again, that's leading them into saying, well, baseball, apple pie, I'm American, I should like baseball. So that's a faulty survey question. But then again, go back and make sure you look at what suspect samples are, detached statistics, and ambiguous averages. Ambiguous averages is just where they change, like within the same discussion of something, they're at one point they're talking about mode, and another time they're talking about mean, or they just use one and don't explain why they chose it. To be honest, this one's pretty hard to put in a small question, just as a hint. Pretty hard to put in ambiguous answer averages as the answer to a single sentence question. So make sure you know what suspect and detached are. Suspect would be like if I was asking people that were leaving the movie, say it was a movie about anything. Let's say it was a movie about, let's say it was an action movie. And you ask people as they left, do you like action movies? Or even, do you like Fast and Furious or something like that? If you already know that they are drawn to a certain genre and then you ask them about that genre, then that's suspect. You're not asking a random population about something. You're asking a specific group of people. So that's not a really good random sample. And then detached statistics is the one that they use in advertising all the time, where they say like it's 30% lower sodium or whatever, but they don't tell you what they don't tell you what it's lower than. Like lower than what? The competitor, their old one, the average one. They don't give you anything. So if they don't have it attached to something, then it's detached. So really quick, just through chapter 1, since that's the one that a lot of people miss on the final because they forget to go back and look at it. So does anybody have anything else that you'd specifically like to do here on the first page? We've got, are you guys pretty okay with midpoints and tallying and finding the frequencies? Just go through here and mark them down. The biggest thing with this is if you're doing a frequency histogram, you have to make sure that you put the points at the midpoint. So like we don't want to put a point at 60 or at 69. We want to put it at the midpoint. So let's say our tally came up that there was 3 of these. We'd want to put the point there. Does that make sense? We want to put it in between. And then however many we get, and then we put the point there. You guys okay with that? What else do we have to do in a frequency polygon? Do you guys remember? You guys remember what we have to do with the, this is the one where we, you know, I haven't tallied this, so I don't know what it is, but you know, you have all these, you have these points. You know, you'd have your points on here wherever they might be, and you connect them all. What do you have to do when you're done?
Connect it to the bottom of the graph.
Yep, don't forget to take this. And again, these aren't right. I didn't tally this. I'm not sure what those actual values are. But once you've got that on there, don't forget to take this back to the beginning and then take this down to the end. You got to anchor it, is what it's called. And again, you're not going to be constructing it. You're just going to be picking the right one. So, but make sure you pick the one that has it anchored. So these should be plotted above the midpoints, and then these should be anchored properly. So, when you're looking at how many values are in a data set, it's not the number of bars. So it's not 1, 2, 3, 4, 5, 6. It's how many are in each. So like this has 3 in it. This has 5 in it. 8, 6, is that 4 and 2? So you would add these up, and whatever that totals, that would be your how many values. It doesn't ask how many classes. These are the classes. There's 6 classes, but in this class there's 3 values. In this class there's 5 values, 8, 6, and so on. So you want to total those up. And if I say anything that doesn't make sense, guys, go ahead and just stop me. Just holler at me and say, wait a minute, explain that again or whatever. Don't hesitate to jump in. Another one that I like to do is this with the cumulative, because a lot of people have a hard time remembering what the cumulative means. So when I say, what does the 0.5906 or 0.6 represent? That's this point right here. So what is that point? When I say what does it represent, I mean, like, what does it mean? So this is a cumulative relative frequency. So this is saying like what percentage or what portion of them. So in this case, that 0.6 is like 60%. And then because it's cumulative, it's that much or below. So this means 60% of the golfers are 59 years old, or what? Does it mean that 60% of them are 59 years old? remember, as you go up with a cumulative, what does it do? Like this ends at 100%.
You produce them together.
Right. So it's that this means that 60% of the golfers are 59 years old or less. So they could be anywhere from
Younger.
Yeah, younger or less or younger. Yeah. I mean, again, it's going to be multiple choice. Just make sure you pick the one that says or less, because one of the choices will be 60% of the golfers are 59 years old. You know, there'll just be a choice where it doesn't say or less or younger or whatever. Just make sure you pick the one, if it's cumulative, that says or less. And make sure it's like in the right order, because another thing I could do is say, like, I don't know, 59 of the golfers are 60 years old. Oops. Which is just backwards, you know. So just look, you know, look for the right order. We want the 59 to be the age. We want the 0.6 to be like the proportion of the percentage. And then you want to, if it's cumulative, you want to make sure that you say or less or younger or whatever. Most people are usually okay with mean, median, and mode. You guys okay with if we skip that one? People usually do pretty well on that one. But this one, on the other hand, people miss a lot. They're okay with the modal class. Modal class is just which one occurs most often. So the modal class in this is the 38 to 46. But people forget how to do the mean. So let's do that one. So in order to get the mean for this, basically what this is saying is we had a bunch of data that was all listed out. And we've combined it into this frequency table, but we've grouped it together. So this is saying we have 5 dishwashers that cost somewhere between 20 and 28 cents per load. But when you put it in the frequency table, you lose exactly what that data was. Like, I don't know if it was like 20, 21, 21, 22, and 28, or any other combination of numbers between 20 and 28. Does that make sense? Like, we've lost that information by putting it in this frequency table. We don't know exactly what those 5 dishwashers had. And so all we can do, because if we actually knew them, we would just add up all the numbers and divide. But we don't know it because it's been put in this table. So what we do is we figure out what this midpoint is. And we say, well, I don't know where all 5 of them were, but I know that they were somewhere between 20 and 28. So I'm just going to use the average. I'm going to use the middle. I'm going to use like a middle number and just assume they were all the middle number, because that's the best I can do. So what's the midpoint of 20 to 28? And it's probably exactly what you think it is. So go ahead and shout out a guess if you think you might know what it is.
24.
Yep, exactly. Because all we do is we just average them. So 20 plus 28 over 2 is 48 over 2, which is 24. So that's the midpoint. And we're going to do that for all of them. So the midpoint for this one, it goes up by 9, it looks like. So this one should be 33. 29 plus 37 over 2. What is that? 30, 62? 66. Hold on a second. Oh, it's not 30, it's 37. Okay, so yeah, 50 and 16, yeah, 66. So 66 divided by 2, which is 33. Once you kind of know what it's going up by, you could just add on, or you could just keep doing the averages if you want to make sure you're not making any mistakes. Okay, so is everybody okay with the midpoints, with how to find those? Okay. My internet, my computer keeps flashing up that my internet connection is unstable. If you lose me, I will come back. I mean, unless I can't. I mean, I'll come back on my phone if I have to. Anyway, once you do that, you multiply these and get a total. So you're saying, okay, well, if I listed this out and I had 5 dishwashers that cost 24 cents a load, that'd be like 5 24s. And if I had 11 dishwashers that were 33 cents, it'd be like 33, 33, 33, you know, etc. until we had 11 of those. And so basically I say, well, 5 24s would be 5 times 24. And you get that total. So 24 times 5 is 120. 33 times 11 is 363. 42 times 12 is 504. And then 51 times 2 is 102. Total that up. 504 plus 102 plus 363 plus 120. You get 1,089. Now, does anybody remember what we do with that? So that would be like if I totaled up all the numbers. You know, if I totaled up 251s, 1242s, 1133s, and so on, I would get 1,089. So what do I do with that number? What would I do if they were all written out and I just added them up individually? What if I did like 24 plus 24 plus 24 plus 24 plus 24? If I added those up, what would I get? What would I do after I added them all up? Like on this one.
Divide them.
Yep. Divide by what?
The number of people or
Yep. In this case, it's dishwashers, but yeah, the number of
midpoints added together.
Yep. Not the midpoints, but the frequency. So like here, if I was going to do this one, I would divide by what? 1, 2, 3, 4, 5, 6, 7, 8. I'd divide by 8 if I was doing the average of this. Here I'm saying I have 5 of these, 11 of these, 12 of these, 2 of these. So I have a total of 4, 5, 10. I have a total of 30. Oh, it's right here too. So there's 30 dishwashers. The cost adds up to 1,089. So 1,089 divided by 30 dishwashers, I get an average cost of 36.3. So you may have forgotten how to do that, but are you guys okay? Like if you practice that, do you think you'd be okay? Okay. One thing that's really great to do is, even though we've gone over some of these problems, I would take this review and just like do it all over and check yourself. Make sure you remember how to do it. You can go back to some of the old reviews and do ones. But just make sure you can get from the beginning of the problem to the end of the problem on your own. You don't want to just look at it and go, oh yeah, I remember how to do that. You will trick yourself into thinking you know how to do it, but you really don't. You don't know. If it's just given to you cold, you don't know how to do it. You understand it when you look at it. Is different than I could be given this problem cold and I could do it from start to finish. So it never hurts to redo a review 2 or 3 different times. Or even to make up like your own review. Like go back to some of the homework problems and be like, okay, well, here's another one like that. Like even writing I used to give extra credit. It's so hard with us online. But in the past, I've given extra credit for students who like wrote their own practice review. Practice review, because I don't need both those things, but they like wrote their own review. I would give people extra credit for that. So that's an idea, is just write your own review by pulling questions off of old homeworks or out of the book or something that you can check, and making your own little review. So I mean, we have a week. I know you have other classes and a life, but we have a week. So is everybody okay with this one? Okay. So but yeah, on this review, if it's on this review, it's probably going to be on the final. So don't, make sure that you understand how to do all of them is what I'm trying to say. Okay, so on this one, it says, that we have an average weight of an adult male bison is 1,500 pounds, has standard deviation, and then it asks the likelihood that you get, actually it just asks to find a z-score. So this is chapter 3. So if you guys remember in chapter 3, the furthest we went with these was just finding the z-score. Later we went further and used the z-score in the chart and stuff, but this just says find the z-score. So do you guys remember how to find the z-score? It's just a real quick little calculation here. Do you remember what to do? I'm going to pull this up really quick too. So you guys all know that you can use the sheet, right? The formula sheet. Yeah, you can either have it printed off or you can click on the one that's in the test. So I'm not gonna wait for it to pull up. I'll pull it up here in a second. But if you do x bar minus mu over sigma, so the value that you're looking at minus the average of the population and divide that by the standard deviation of the population, that's the z-score. So in this case, what's the x bar? What's the average of the, or not the, it's actually not x bar, it's actually just x. So what's the x?
It'd be the bison weighing 1,850 pounds.
Yep, and then the 1,500 is the population average, right? So we put those in. So we put in 1,850 minus 1,500. And then the sigma is the 290, right? And so 350 divided by 290, which we know will go in one time plus some extra, or whatever that is. It's about 1.21. Definitely make sure you know how to do that, and definitely make sure that when you do these, don't flip these. I mean, that'll be one of the choices, is this answer, but flip, a negative 1.21. If the thing you're looking at is above average, you should get a positive. If it's below average, so like if I had asked the z-score for a bison weighing 1,300 pounds, that would be negative because it's underweight. So 1,500, and we have a bison is average. Oops, hold on, the pin got stuck. Sorry, the pin got stuck. Okay, so 1,500, and this bison is at 1,850. So he's above average. You should have a positive z-score. Everybody okay with that one? And if you're looking on the formula sheet, I got this formula sheet pulled up. It is over here in chapter 6. It's right here. It doesn't have it, they don't put it with chapter 3, and I'm not sure why. I kind of wish they would, but it is over here in chapter 6. So z-score is x minus mu over sigma. All right. Again, absolutely positively going to be on the final a question like number 10. This is just a real basic, it's one of those things that if you've had some probability, you really should know how to do. So I really just picked out here, what do I have? 4 questions out of chapter 4 that are just very, like to me, the most important. Like if you've had some probability, you should know how to do this. So on this one, this is where you have a sequence of events happening. So here I have gumballs, but it could be chips out of a hat or a deck of cards or something like that. If I do a deck of cards, I'll give you a picture of the deck of cards. Was there one on the last test that used a deck of cards? Or not on the last test, but on the chapter 4 test? I want to say there was, wasn't there? It had the little picture of the cards, right? Anyway, if I ask you something about a deck of cards, I will give you a picture of a deck of cards. So you don't have to worry like, you know, oh, I always forget about what's in the deck of cards. But the other thing I could do, like I said, is balls, gumballs, chips, whatever. So in this case, it says, what's the probability of getting first a grape and then a cherry and then a lemon? So what's the probability that that's the order that the gumballs come out in? One thing that's really important is it says that each ball was removed and not replaced, which makes sense for gumballs. You can't really, you know, if you're doing a gumball machine, you can't really put them back in. So what's the probability on this first turn that I'm going to get a grape? What's that probability?
Would it be 1 out of 150?
150 I agree with, but one would mean 1 out of 150 would mean there's only one grape.
60 out of 150. Okay.
There you go. You got it. So out of those 150 gumballs, that's just totaling up to 60 plus the 40 plus the 50. So out of a total of 150, I have 60 that are grape. Okay. And then I'm going to multiply that by the chances of getting a cherry the second time. So what's the probability of getting a cherry flavor on the second one?
That'll be 90 out of 110. Nope, I'm wrong. 40 out of 110.
Okay, so 40 out of 100 and...
Is it still 50? Because since we're removing it and not replacing it, that's why I got 110.
Well, so
Okay.
so how many did we remove on the first draw though? So we had 150. How many did we take out? I think Ruby
The
said
60. So, oh, I'm sorry, 40 out of 90.
Yep, it'd be 149. Because if you think about your gumball machine.
Oh, because of the one. Got it. Okay.
Yeah, you have all these gumballs in here, and there's 150 of them. You took out one grape. That's all you took out on that first draw. So if there were 150 to begin with, now there's only 149. You guys good? It's been a minute since you guys had to do these problems. Yeah. Okay, so then on the lemon, we haven't taken out any lemons, so there's still 50 lemon, but we didn't replace the grape one or the cherry one, so now we only have 148. Perfect. And I would definitely say, do not do this by hand. You passed that class, okay? You passed the class on multiplying fractions. Don't do that in your head. Don't do it by hand. Just figure out how to do it on your calculator. Type this in and see what you get. If you don't know how, look it up. If you can't find it, ask me, because I know how to do it on all the, I know how to do it on a TI graphing. I know how to do it on the Texas Instrument one that I recommended, the multi-view. So if you search it and you can't find it, let me know. But anyway, do on your calculator just the fraction 60 over 150 times the fraction 40 over 149 times the fraction 50 over 148, and it'll probably come up as a decimal, which is fine. So it's 0.036 is what this comes out to be, or about 3.6%. What do you guys think? You pretty okay on that one? Let me throw another one up. What if I said, what's the probability of doing, of getting lemon, then another lemon, then a grape?
And we're doing the same, not replacing it.
Yep, not replacing it.
Okay.
So this is similar, but it's a little bit different because I'm repeating one. So lemon on the first one is 50 out of 150, right? But here's the difference because I'm repeating one. What's the probability of getting a lemon on the second draw? How many lemons do I have left?
It'll be 49 out of 149, right?
Perfect. So there's only 49 lemons because I already took a lemon out, and there's only 149 total. And then grape is 60 because I haven't taken any grapes out, and there's only 148. So the bottom always lowers like this. Whether or not this number on top lowers depends on if I'm repeating something or not. So then whatever that equals. It's going to be a little bit lower because I've got 50, 49, and 60 instead of 60, 40, and 50. Oh, wait, actually, it might not be. 50 times. $49 out of 149. No, it's a little bit higher actually. So this is 0.044 approximately. I can't remember on the final if I have it as a decimal or a percent. You guys are okay either way, right? Okay. The biggest thing with this is just remember you have to multiply the possibilities, and then if it's not replacing, you have to reduce the total down as you go. That's the biggest key there. There will absolutely be one of these on the final. But, you know, if you understand it, that's a good thing because you're like, yay, there's 3 points I'll get for sure. Okay, so on this, let's come back to 11 and we'll do 12 and 13 really quick. So on 12, this is absolutely just the definition of mutually exclusive. Two events that can't occur at the same time are mutually exclusive. The other term that I might ask you about is independent. So you might want to look up in that one, but mutually exclusive and independent are two of the main concepts from chapter 4. Independent means they don't affect each other. They can occur at the same time, but they don't affect each other. So that would be like flipping a coin and getting a tail and rolling a dice and getting a 5. Those are independent of each other. They can happen at the same time, but they don't affect each other. So if you think about it like people, mutually exclusive, we usually use in everyday language like a relationship. So if somebody's in a mutually exclusive relationship, it means they don't date two different people at the same time. They don't occur at the same time. Independent would be like two people who don't affect each other's lives. Like I'm completely dependent from my parents. So what my parents do and what I do doesn't affect each other. Or my friend and I are both very independent people. We make our own decisions. Means like my friend might say, well, I'm going to go to the movie, and I'm going to say, oh, I'm going to go to the mall, because we're independent of each other and we don't affect each other. We can happen at the same time. We just don't affect each other. And then this number 13, this one's kind of a recognition problem. What's a number of different ways 4 signal flags could be run up a pole if there's 15 to choose from? What type of problem is that? Again, it's been a minute since you've done chapter 4. But those were a very specific type where you had a total something and you were going to pick out a certain number of them. You guys remember? Whoops, I wrote that backwards. These were, let me pop open the thing here. These were the ones down here, the combinations and permutations, the NPR and the NCR. That's when you have a certain number of things and you're going to put them in order. Beyond knowing that it's a NPR or that's a permutation or combination problem, one of them the order matters and one of them the order doesn't matter. If you guys remember which one is which. This one it matters. This one the order does not matter. So on a permutation, the order matters. On a combination, the order doesn't matter. The way I remember it is legitimately, I think of the fact that a combination lock is named completely wrong. Because a combination lock, you know, like a master lock, the order matters. And also you can repeat numbers. Well, that blows it. It's neither a permutation nor a combination lock, because you can't, if permutations and combinations, you can't repeat things. And if the order matters, it's supposed to be a permutation. So which of these is this? Do you think the order matters when you're talking about signal flags? If you're trying to signal, do you think the flags in a different order would mean something different? It does.
I think it matters.
Yeah, it matters. So like if you had a pole and you put up a flag, you know, that looked like this, if you put those up in a different order, ooh, those are funny looking flags. If you put those up in a different order, it would mean something different. So these in order, it's the same as if you put, you know, DOG versus GOD. You know, the letters in a different order matter, the flags in a different order matter. You know, that's dog, that's God, but not the same word. So these in a different order would matter. So we want to use a permutation. And what's our number in front?
$15.
And then P4. If you don't know, again, if you don't know how to do that on your calculator and you're doing it the long way with the factorials, figure out how to do it on your calculator. Almost all the calculators nowadays will have it. Like on the TI Multiview, it's under the PRB button. A lot of them it'll be under PRB, or it'll be like above a button. But all you have to do is push 15.
What about for the test?
Yeah, just, you can use your calculator on the test. Oh, are you using the calculator on the computer?
I mean, where would that be if you're using the one? Yeah.
Wow, I don't know. I don't know. I'd have to get in and try it. Go ahead and shoot me an email and I'll get into the test and pull up the calculator and look for it. It's got to be there. Yeah. But so you don't have a regular, like, you just have been using your phone when you do your homework and stuff?
Yeah, I mean, I have a basic calculator, and I had a scientific one, but I mean,
you're not as familiar with it. Yeah. If nothing else, if it's not on the, if I can't find it on the one on the, it really should be there on the one on the computer. If not, you could figure out how to do it on your calculator and just use the calculator for that one problem if you wanted to, because you're allowed a calculator, so you could do that. Okay, so anyway, if you're doing this one right, you should get 32,760. And just FYI, if you did a 15C4 by accident, you still on this problem get 2 points. Because you still knew it was 15 and 4. You still knew it was a permutation or combination problem. You just picked the wrong one. So you still get 2 out of 3 points on it. So, all right. And then the last one on this, And I can stay past 3. I was thinking I might stay till like 3:15, 3:30. So if you guys can stay, you're welcome to stay. If you have to go, I will not be offended. Okay, so the other one that you will definitely absolutely see on the test is either this kind of problem, which is an or problem, or you may see a given problem. So one of these two is going to be, I probably won't put both, but I'll put one or the other. And the way you know it's one of these is you're going to see a table, because I like to give it in a table. So if it's an or problem, so in this case, the probability that you're on the 3rd floor, that's kind of a funny typo. It's supposed to be the 2nd floor. Okay, so you're on the 2nd floor, or it has 3 bedrooms. You don't have to use one of those crazy formulas off the sheet. If you understand what this means, you can just count them, which I would highly recommend. So 2nd floor or 3 bedroom. That's this row and this column. You just don't want to say, oh, well, there's 6 here and there's 5 here, so there's 11. That's not true. You have to count them, but don't double count this one. So 2, 4, 5, 6, 7, 8 total. You guys okay with where I got that? Just the numbers, but don't count this one twice. Does that make sense? Okay. And then just out of the total. So what are there? 8, 9, 10, 11, 12, 13. I think there's 17. So 8 out of the 17 are either a 2nd bedroom or a 2nd floor or a 3rd bedroom, or both. It could be both. It just needs to be one or the other. Let me throw another one up here. So if I said, what's the probability that your 1st floor or 2 bedroom? Well, you would just go up here to your thing, and you'd circle all the 1st floors, all the 2 bedrooms, and just count them up. So 3, 4, 5, 6, 7, 8, 9, 10, 11 out of the 17 are either on the 1st floor or a 2 bedroom or both. There's one that's both. We just don't want to count it twice. You guys okay with that one? Okay. The other thing I could ask, and there's not one on here, you could go back and look at some of the examples or whatnot, but the other type that I could do is a given one. So what's the probability that it's 2nd floor given that it's a 3 bedroom? Well, this changes the actual bottom number. It makes the bottom number not the same, because we're saying we want the probability that it's the 2nd floor if you already know that it's a 3 bedroom apartment. So we're only looking at these ones. We know it's not either of these. So this changes that bottom number to what? How many total?
4.
Yep, perfect. And 2nd floor, there's 2 of them. So once you know that it's a 3 bedroom apartment, you have a 2 and 4 or a 50-50 chance that it's a 2nd floor apartment. I always tell students, it's not really mathematically, technically perfect, but think of it like a fraction that's gotten turned sideways. So you notice that the 2 is the 2nd bedroom and the 4 is the 2 is the 2nd floor and the 4 is the 3 bedroom. So it's like this is your new denominator and this is your numerator. So you get your new numerator or new denominator and then figure out the numerator. And these can go the other way. So what's the probability that it's a 1 bedroom given that it's on the 3rd floor. So here, what are we going to do for our bottom number? We're given that it's
We're
where?
gonna add up on the 3rd floor.
Yep. Or ignore everything that's not a 3rd floor, right? So we're not worried about this. We're not worried about 1st floors or 2nd floors. We're only worried about 3rd floors. So that would be 6. And the chance that the probability it's a 1-bedroom, knowing it's a 3rd floor apartment, there's only one of those. So if somebody says, I live on the 3rd floor, it'd be a pretty good guess to say, oh, you have a 2-bedroom. They'd be like, no, I've got the one that's a 1-bedroom on the 3rd floor. But once you're on the 3rd floor, you only have a 1 in 6 chance that it's a 1-bedroom and a 1 in 6 chance that it's a 3-bedroom. Because most of the ones on the 3rd floor are 4-bedroom or 2-bedroom. Does that make sense? So this one you dump out, you change that bottom denominator. Change the denominator, the bottom number. Because it means we're throwing out everything that's not that given part of it. All right. So that's it for chapter 4. And again, the ones we just talked about, just doing something in a sequence, drawings in a sequence, the 2 different kind of table problems, mutually exclusive, independent, and then permutation combination. That's pretty much all I'm going to cover in chapter 4. That's like the highlights from chapter 4. So, chapter 5, again, it's been a little bit because you just got done doing the 7, you just got done with the 7-8 test, or you're just taking, everybody just got done with the 7-8 test. So, do you guys remember from chapter 6, what makes one of these a probability distribution? What do you have to look for in that thing?
Is that where you have to see if it's evenly distributed?
No, this one doesn't have to be evenly distributed. It could be, but this one doesn't have to be. That's if it's a normal distribution, is what you're thinking of. This one is just saying that I have a 19% chance that I'm going to get a -2. Whatever this is, it could be like if you think of it like a game. Maybe it's a game where you have a 19% chance that you're going to lose $2, or a 26% chance that you're going to lose $1. What's this mean though? What's a probability of -0.21? What does that mean? Does that even make sense for probability?
Not possible?
Not possible is actually 0. So this is like more than not possible, which that doesn't really make sense, right? Like more than not possible. So this one is not a probability distribution because you cannot have a negative number on the bottom. On top is fine, but you can't have a negative probability. Probabilities have to be, the probability of something happening has to be somewhere between 0 and 1. 0 means it absolutely can't happen. 1 means it absolutely has to happen. So this doesn't work for a probability distribution. What else should these all add up to be if it's all the probabilities? So like, let's say I do like, do something easy, like heads and tails on a dice. Heads, 0.5, tails, 0.5. What do these have to add up to be?
1.
1. That's everything that could happen, so these should total 1. Now this one technically does total 1, but it's got a negative in it, so that doesn't work. So in order to be a probability distribution, these bottom numbers should be somewhere between 0 and 1, and when you add them up, you should get 1. So like this is a really simplistic one. This is just supposed to be everything that could happen. And this bottom is just supposed to be the chances of it happening. So 50-50. If I did a regular die, this would be a example of a symmetric one like you were asking about. You'd have 1/6, 1/6, 1/6, 1/6, 1/6, then 1/6. Because every side of that die has a 1/6 chance of being rolled. The other thing that I might ask in chapter 5 is how to find the mean of one of these. So this one we can't use because it isn't one. So I'll make another one up. What if I had, I don't know, let's say your possible outcomes are 2, 4, or 6. And the probability of this one happening is 0.4. The probability of this one happening is 0.5. And the probability of this one happening is 0.1. I don't know what this is. Some game, some spinner or something. How would I find the average of this? You guys remember how to do that?
Don't you put those in fractions and multiply them times each other?
Mm-hmm. Yep, and you don't even have to put it in fractions, but you just multiply them. And then as you multiply, you sum them up. So 2 times 0.4 plus 4 times 0.5 plus 6 times 0.1. We also did variance and standard deviation, but I won't ask you that on the final. That's the one where you had to square the top one. So like 2 squared times 0.4 and 4. I won't ask you that one. But I could ask you a mean. So just, multiply them up, add them up. So what's this one? 8, 2.8, 2.8. I think it's 3.4. So we're saying that the average thing that if you did this a whole bunch of times and divided by how many times you did it, you should average about 3.4. Which makes sense because, you have a 90% chance that you're going to get a 2 or a 4. Occasionally you'll get a 6, but most of the time you're going to get a 2 or 4. So it makes sense that the average is somewhere between 2 and 4. All right, and then this one, you can put a big star by this one. There will, again, absolutely, positively be one of these kind of problems on this. So if you get done with chapter 5 and you haven't run across one of these, you missed it. It's there. And this is another one that's really important with the recognition, kind of like the permutation and combinations. You just have to recognize that this is what you're looking at. But again, there's only going to be 2 or 3 questions out of chapter 5, and there is going to be one of these. So if you get done with chapter 5, here's your formula sheet. You get done with chapter 5. Oh, why is my computer being so obstinate today? It won't let me move that thing. Why will you not move? All right, I'm going to clear this just so all that stuff's not in front. All right, so if you get done with chapter 5 and you haven't done, there it goes, one of these kind of problems, you missed it, okay? That's what this kind of problem is. The binomial probability. And this thing right here in front, that is a combination. So you don't have to do this, you can just do this. So let me write it down for the problem. So this is a binomial probability. The way we know it's a binomial probability is because it has it's this or it's not this kind of scenario. So in this case, a pet supplier has a stock of parakeets, 20% which are blue, which means the rest of them are not blue. So binomial, blue, not blue. And then you have a certain number that you're getting and you want a certain number that meet that criteria. So in this case, you're getting 7 parakeets and you want 2 that are blue. So our formula is P of X equals NCX times P to the X times Q to the N minus X. So what is all of that in this problem? Well, N is how many you're getting. So how many are you getting?
7.
7, perfect. X is how many of those that you want to meet the criteria, that you want to be a, what we call a success in statistics. So how many do you want to be a success of getting a blue one?
2.
2. What's the probability that you get a blue one? On a single, like when they pull out of their stock, what's the chance that they get a blue one?
One out of 7.
No, because they've got
2.
this huge stock. Yeah, 20%, right?
Right.
Yeah, so it's not based on how many we're getting, it's based on their stock. So their stock is, you know, I'm assuming they have, you know, a big aviary and they have bunches of parakeets in there and 20% of them are blue. So you have a 20% chance that each time that they get you your parakeet for your shipment, they have a chance, 20% chance it's going to be blue. So what's the chances that it's not blue on just an individual parakeet?
80%.
Yep. Because these have to add up to 100%. If you got a 20% chance that it's blue, you have an 80% chance that it's not blue. So now we're ready to fill this in. N is 7. Choose 2. So 7, choose 2. Then you get the probability of success, which is 0.2. And the probability of failure, in this case, a non-blue parakeet is considered a failure, 0.8. What are the chance, or how many of the blue do we want? 2. So this is the probability of blue and the number of blue. And then this is the probability of not blue. And how many not blues are we going to get? This number actually isn't in the problem anywhere. We have to do it ourselves. So if we have 2 that are blue, how many are not blue? 5. Perfect. You got it. And that's what you want to type in your calculator. So this is probability of success, probability of failure. This is the number of successes we want and the number of failures we want. And when I do it, I literally write down the bottom numbers first and then do the tops, because the bottom numbers have to add to 1 and the 2 top numbers have to add up to 7. So, you know, they kind of go together. So I'll do bottom, bottom, top, top. So if you just type this in, 7, choose 2. Times 0.2 to the power of 2 times 0.8 to the power of 5. It comes out to be about a 27.5% chance. The reason that's so high is that's about the proportion you would anticipate with 20%. You would expect, you know, 20% of 7 is between 1 and 2. So you expect to get 1 or 2 blue ones. So this is going to be pretty high. If I said, what's the chance of getting all 7 blue? That would be a really small number, because you wouldn't expect to get all 7 of them blue. So if we did a 0.27 and a 0.80, that would be a really small number. Definitely going to see one of these, okay? So you can go back and look at your homework. Don't forget you have a complete ebook in your Connect Math account too. So you can go to the ebook and look at like problems at the end of a chapter and check them in the back of the book, just like you would in a regular textbook. So if you're just looking for some extra problems to do. Again, I know you're not like dying to do math problems for the next week, but if you know you need a few more to practice. So since you guys just got done with 7 and 8, is there anything out of 7, 8, or 9 that you guys want to go over? Because what I'm kind of thinking is we could maybe finish up 6. Oh, we haven't done 10 either. But remember that anything we didn't get through, you can go back and watch that other video that I did
Can we
before.
7?
What do you want to do?
The 27?
27? Sure. So this one?
Yes, ma'am.
Okay. So what I'll probably do, let's do this one, and actually let's go do the one for chapter 9, and then we'll call it a day. Anything else? You guys can go back and watch the video. You can also try to do it and check it with the key even before you watch the video would be a good thing too. Okay, so I gotta move our little faces here. Move out of the way here. Okay. All right, so it's been claimed that at UCLA, 43% of students live on campus. This researcher, Ebony Robinson, believes it might be higher. She takes a sample. Okay. So of course we know it's a hypothesis test because it's got it all laid out here. So what's our null hypothesis? Like what's the base assumption? Are we talking about, first of all, are we talking about a mean or a proportion?
I was having trouble with this one, even in the connection.
Yeah, this is a proportion because we're talking about like a percentage of them. So you can think of a proportion problem can always be thought of as a percentage problem too. So in this case, the proportion being 0.43, that's the null hypothesis. That's the assumption. And she thinks that that proportion might be what?
Higher.
Higher. So she thinks it might be higher than 43, so proportion greater than 0.43. So that's our starting idea. Our critical values, I really like to draw the picture for this. So critical values are, we are assuming 0.43. What did she, hold on a second. Hold on, this isn't what I want to do here. Okay, so for our critical values, we're going to have greater than, so we're going to have up here, we're going to have a critical value and we're going to be checking to see if it falls above that critical value or not. So we need to know our alpha, which is 0.05 rather. We need to know what tail. Is it one tail or two tail?
I don't know.
This is considered one tail. If we do a not equals, that's two tails. But since this is greater than, it's one tail. So you see how when I shaded it?
It goes on the other side then?
Yeah, there's one tail right, which this one's one tail right, and one tail left would be over here.
Got it.
So
okay.
This would be two tail. This would be one tail left, and then we have a one tail right.
Mhm.
So this is one tail.
Mhm.
And then a proportion is always a z test. So if it's a mean and we have sigma, that's a z test. If it's a mean and we only have s, which means we only have the standard deviation of the sample, that's a t, and we have to use degrees of freedom. And then if it's a proportion, that's a z again. So those are the only options. The only time you use t is if it's a mean and you don't have the standard deviation of the population. So this is a one tail z test with alpha 0.5. So on the chart, so we're going to look for, again, one tail alpha 0.05, one tail 0.05, and then it's got to be a z test, and z test is at way at the bottom. See right here, it has a z. See right there? So this is the one that we want right there. I think, was that the right, am I in the right column? Yeah. One tail, 0.05, all the way to the bottom. That's our test value, or our critical value. So that's going to go right here. Okay, and then while we've got this open, let me write down the formula. So to get our test value, we're going to use this formula right here. Okay, so I'm going to write it right here. I don't know if it's going to, hopefully it'll look decent when I go back to the other screen, but PQ over N. So Z equals P hat minus P over the square root of PQ over N. Okay, I'll be right back. I have a really mad cat because I'm not letting her in and she's meowing. Sorry about that. She was literally at my study window and she's like, I can see you right there. Why are you not letting me in? All right, so let's see, let's get rid of all this extra stuff. So are you okay with this, with where we're at so far? You okay with where we got the hypothesis statement? You're good with that? You okay with where we got the 1.645? Okay. So now we just have to plug these values in and see if we're below that value or above that value. So P hat is the sample proportion. So we have to look at what she got in her sample. I'm going to shift this over. So what did she get in her sample for a proportion?
The more the over 43, higher than 43?
Well, we don't know. I mean, yes, but we want to know what she actually got in her sample.
Oh.
It's a little tricky, and this
That's
is probably why you were stuck. Yeah, you have to actually calculate this.
Mm-hmm.
We actually have to figure out what her percentage was. It was 112 out of 250. We actually have to calculate it ourselves.
0.448.
Okay. And yeah, and you want to go out 2 decimals is good on this. It's usually like 1 decimal past the hypothesis statement one. So 0.448. And then we're going to subtract the 0.43. The 0.43 is the P. See how we have P equals here, and then we put the same number in here. And then on the bottom, be really careful, because this is actually something I do sometimes as a mistake. Don't put P hat here. This is supposed to be P, so it's the 0.43 again. And then the bottom number is N, so that's the 250. What do you think this number is? This Q. And a hint, it's the same way we found Q when we were doing that binomial.
0.57.
Perfect. Because the P and the Q always have to add up to 100%. And then now it's a matter of calculating it. I usually will write the top down. So this is 0.018. And then I'll do the bottom on my calculator and then do 0.018 divided by answer.
So then it's 1.59. Do we round that up?
That's not what I got.
Oh, okay. Hold
But
on.
I might have put it in wrong too. Just a second. 0.43 times
Oh,
0.5
I put it in wrong. I'm missing a number. Huh.
equals square root of the answer equals. Yeah, I got 0.57. Is that what you guys got? I'm not gonna rewrite that down, but when I typed it in, I got about 0.57.
Yes, I'm sorry. I missed a 4.
Yeah, and that's the thing with these, like when you're doing it on the test, you know, you're picking out the one that's correct. So if none of them has the right number, just type it in again because something went wrong. So now this number is right here. You know, it's about here. So are we in the critical region or are we not in the critical region?
We're not.
Right. So we do not reject because we are not in the critical region. So if you are not in the critical region, you do not reject, and there is not enough evidence. Like all the nots go together and all the ises go together. So if it is in the critical region, we do reject, and there is enough evidence. If we're not in the critical region, we do not reject, and there is not enough evidence. So they all go together.
Mm-hmm.
I would guess on this, if you were having a hard time, it was probably figuring out what this was and also realizing whether it was supposed to be a Z or a T. But proportions are always Z's. The only time you use a T is if it's a mean with only the sample standard deviation given. That's the only time you use T.
Okay. Thank you very much.
No problem.
Can you refresh my memory on how to tell if it's a two-tail? Is it if it says find the difference? Is that when you can tell?
So like for this one, if I'd wanted this to be a two-tail, it would have said researcher Ebony Robertson believes that may not be true, or researcher Ebony Robertson believes it might be different than that. So it wouldn't specify up or down. It would just say different or not the same or something like that. If it specifies higher or lower, so if it specifies, let me clear all this up. So if it specifies higher or above or more or anything like that, it would be a right tail.
Okay.
That'd be a right one tail. And then if it says, you know, lower, below, whatever, that would be a left one tail. Which just means when you go to the chart, you'd put a negative in there instead of, you take whatever was on the chart, but you put it as negative. And then if it says anything like change, different, or like it's not right, something like that, it doesn't specify above, below, or whatever, then that's where you get like we just did, or like a two tail. This
Did we
one you'd
ever
have a greater than, less than, not equal. What's that?
did you ever specify that to us when we were doing that? Because I don't remember. And every time I got these type of questions, like I was on it. And I think the last time I did it in Connect Math, I think there were only about 4 to 6 questions in each section.
Mhm.
And I kid you not, I think I stayed on them for like 7 hours. It was so
Oh, no.
complicated for me.
Yeah,
I think
and
I
it's
found it
kind of-
on your Zooms.
Yeah, I would say it should be in the chapter 8 Zoom, or
Okay.
the chapter 8 if you go back and look at chapter 8 reviews. Let me see really quick. So like it should be, yeah, it's not pulling up, sorry. So, but if you go back and you look at the Zooms,
okay.
it should be in there, and there should be like a
Mhm.
chapter 8 review. And then there's the review for this. So, and there should be some examples. Not some, like I should say it several times. This one right here, you suspect this is wrong. So that's a not equals, and that would be a two tail.
Okay.
A sample of 58 people. Here, less than. So this one says, can it be concluded the average number of normal functioning hours is less than? So that one would be a less than, and it'd be a one tail left. So, yeah.
Okay.
So the other one that I wanted to do, I have to get the computer to cooperate and open this up. Ah, there we go. Okay. I was having a little bit of a. So the only other kind, only kind that you have not been actually tested on in any of the tests yet, that it's on the final, but it hasn't been on any of the tests yet, is the type from chapter 9. Which that homework isn't actually due till Sunday, is it?
Right.
So you guys might not have done it yet. I'll just go through this really quickly. So in chapter 9, you're going to have where you have 2 different groups that you're trying to compare. So I'll just run through one really quick, but you'll want to watch the Zoom and you'll want to do the homework and all that. Oh, there's my kids. There's my kids in my really messy home screen. Don't look at my messy home screen.
It's okay.
Look
You're
at
a
that.
teacher.
Lord, I need to clean those up a little bit.
You know what? Now that I remember, in one of the videos that you posted for the class lectures,
Mhm.
there was, an equation that you did wrong.
Oh,
And
really?
you got your answer. Yeah, you got your answer, but it was not the correct answer. But I
Do you
mean,
know which one it
I
was,
guess no one noticed.
do you know
I'm
which
sorry.
one it was in? 'Cause
No.
I can fix that. Yeah, because I could go back and fix it. It'd take a little bit of doing, but I could at least put a note in the comment for the video that there was a mistake. Yeah,
And
either
I didn't
people
bother
saw
to
it.
say anything. It's been
Yeah,
2 years.
nobody said
I'm
anything.
like,
So
no one. Someone would have told you something.
I'm actually impressed that out of all the videos, it's the only mistake that you found. Because I'm trying to talk and write.
Because you did go back to many more in the previous videos, and you're like, oh no, this one's wrong. I numbered it wrong, or the number's wrong. You went back, re-erased it, and then rewrote it. But that one you didn't, and I guess because you were going so fast. But I mean, I got the answer, and I understood what it meant.
Well, I must have, yeah. If you can remember, if you ever see which one it is, let me know. So again,
Okay.
I understand this might be the first time you've seen these, but it'll be nice to just run through one together really quick. So when you get to chapter 9, what you're going to see is that where you're comparing, it's a different type of hypothesis test where you're comparing two different groups. So in this case, it says a local charity believes they receive more money from the people in River Heights neighborhood than Lakeview. So those are our two groups. That's like our group 1 and our group 2. They conduct a survey of 24 people from each neighborhood and record the results. So there's a little table here where the results are recorded, and I will definitely give that to you on the test. So you don't have to pull so much out of the words or out of the paragraph. So in this case, when you're talking about this kind from chapter 9, the null hypothesis is always going to be that mu1 equals mu2, that the two means are equal to each other. So it's a little weird because there's actually no numbers in it. We don't really care what they are, what the numbers are. What we're just trying to see is, are the two groups the same or are the two groups not the same? So the mean of 1 and the mean of 2. And then the alternative hypothesis, in this case, it thinks River Heights is more. So that would be our mean 1 is more than our mean 2, because we're thinking of this as our group 1 and our group 2. And then we do our critical values the same way. In this case, were we given the sigma or were we only given an S? And here's the information. So it says right here, you were only given the S's. So this is a t-test. So it's a t-test. Our N is 24, so our degrees of freedom is 23, and our alpha is 0.01. Again, I know this is kind of fast, but you can, at least you have seen one, and then when you go watch the video, you'll be like, oh, okay, I see how it all fits together. Okay, so greater than, this is another greater than, so it's just the right tail. And we're going to go to that chart. So we've got a alpha 0.01, degrees of freedom 23, one tail. So alpha 0.01, degrees of freedom 23, we're right here. It's actually 2.500. So far, so good?
Yes.
Okay. And then our test value, this is the biggest difference for these kind of problems, is the test value is kind of long. So we're going to do on the top, hold on, I'm going to open this and move it over so I can write this down right. want to make sure I use all the right letters. So it's x bar 1 minus x bar 2. And then on the bottom, we have s1 squared over n plus s sub 2 squared over n. So it's kind of long, but there'll only be one of these on the test. And I think on your homework, there's maybe 3, 4 questions at tops. So if we plug these in, x bar 1 and x bar 2 are 35 and 25. Then on the bottom, our S1 and our S2 are 5 and 8. And then in this case, our ends are the same. So this is 24 and 24. So another case where it's definitely helps to just do the bottom on its own because it's so big. 5 squared divided by 24 plus 8 squared divided by 24. And I got 5.19. Actually got a really big number. Well, big for a Z. So what do you guys think? Does that all make sense so far?
Yes.
Again, it'll probably take a little practice to understand how to set it up and stuff because it's a little different, but does it make sense where we got everything from?
Yes.
And then if I look at where that is in comparison, well, 5.19 is way up here. And that's like way up here. So it's definitely up in the rejection region. So we are going to reject the null hypothesis because we are in the critical region. And so there is enough evidence to support that the charity receives more money from River Heights than it does from Lakeview on average. And so that's the very last topic you guys have to learn is how to do one of these, because there'll be one of these on the final. So you have like 3 or 4 homework problems on this, and then, you know, study it so that you can do it on the final. And that's the very last new thing that you have to learn.
Okay. I appreciate it. Thank you very much.
Thank you. Shelby, Patricia, Ruby, you guys have any questions? Are you guys good? And even this is going to be recorded and put up. So if you want to rewatch this at all, if you're not already tired of listening to me. Yeah, and don't hesitate, just because you know, we're done today with the review, don't hesitate to shoot me an email if you have a question on a homework assignment or anything. Feel free to shoot me an email sometime over the next few days. And just make sure you don't start your final at 10 o'clock on Friday night next week. So often I'll have people say, well, I had a plan to do it when I got home from work Friday night, which I get. I know everybody's super busy, but unless it's like the only time you can take it, try to take it so that you have, you know, chance to take care of like if there's a technical problem or some emergency arises or something like that. Because, you know, yeah, we can figure it out if something like that happens, but you're going to be stressed. If you miss your final, you're going to have a panic attack until you get a hold of me and figure out what we're going to do about it. And that's just easier to avoid altogether. So, yeah, so try to start it earlier on Friday, or even do it a day or 2 ahead if you feel like you're ready. So good luck finishing up, guys. And good luck with your studies. Maybe we can be back to normal and actually in-person regular school someday. Has anybody not been on campus at all this semester? No, not at all. I've only been 3 times, 4 times since March. And that was all in the last couple weeks. I hadn't been at all before that either. So
Wow.
trying to be safe. All right. Well,
Yeah.
stay safe, stay healthy, and
Right.
very, very best of luck on your final.
Thank you.
Thank you, ladies. Notice it's only the girls that showed up. To give the guys a hard time. Hey, bye-bye.
I guess so. All right. Take care, guys. Bye.
Goodbye.